So what I need now to do is to register that specific energy per atom for a specific temperature and do the same plots you did for temperature versus energy per atom. Right? Is that what I have to do?
So you will do very beginning, you do MVT example first. Then you just need to change the temperature one to another. Yeah. Already see the Professor Sulaidi's lecture. You see, you will have two phases. One is just the pre-phase. You need to go to the equilibrium first. Then you do a function phase. You take the data for the analysis.
Okay.
Yeah. So you need to judge when your system becomes equilibrium at your temperature your desired, your set.
Doctor, can you allow me to share my screen now?
Oh, it's better. Yeah, please. Yes.
Just a minute.
Yeah.
Just.
Wait 1 second. I may need to set your
Yeah, please.
Yeah. I already give you the.
Okay, so now I will share my screen. And I will come here and 2 minutes.
Yeah.
Plot, right? From Python.
Yes. Okay.
Yeah, this is a lot. And register the energy versus atom for each specific temperature, right?
Yeah, this one is your mileage may be different. All right, but this you will have something similar. Yeah. So you will see the first point. Let's say 0.3. This is just the preparing phase. All right, this is just preparing. I mean equilibrium phase. Then after that, there's so you do the average. Because you will see the data is fluctuation, you take the average. Do you guys know how to do the average?
Can I do it visually? I will say
no, you can do just in one line in the Python code. Yeah, it's very simple. All right. Okay, I will show you later. Yeah, I will demo later.
Okay, and then I have to generate this.
Yes, you have to. Yes, you need to plot the energy versus your temperature. Yeah.
Should I do it by
it's not that your number will be different. You may have 1.1, 1.2, then 1.9, etc. You need to your number is different, all right?
Look,
and the energy and your system, because we have different potentials. This just
Yeah, and after that, doctor, I state that the melting temperature is 95, and then I move to the other size and say that the melting temperature is likely 98 or something, and I finish like this, right?
Yes. For example, if you do it in 3 by 3 by 3, you may have 94, and if you do 4 by 4 by 4, you will go to 98. So 5 by 5 by 5, you may have 100, something like that. Yeah, there's changing. Yeah, the critical temperature, it's changing. That's called system size effect. That's called the size effect. This size effect is artificial because your size is limited, is small. So it's the sum of the principle is the larger the better. But if you take a larger system, it will be more difficult because for 3 by 3, sorry, you have 1 million Monte Carlo step. It's enough in general. But if you go 5 by 5 by 5, you may need 10 million steps.
10 million.
So you need to find your system's behavior. No one really knows. You need to.
For sure, doctor.
Yeah.
But doctor, I have something for you to show us today. Can you just go a little bit for the radial distribution function and show us how it works in today's session? Because I didn't know what's the how can we use it or benefit from it in this project.
Okay, for the RDF, there's have you go through the tutorial 3? Tutorial 3?
No, actually,
you will activate it, and then you plot it. Yeah.
Mm-hmm.
The tutorial 3, especially just for the RDF radio distribution function. Then in your control file, you will have one comment. Comment. Yeah. Then you will write out a file. Then you just plot the data from that file. You will get the plot.
Okay. Thank you, Doctor. I'll stop sharing now.
Yeah.
And thank you very much.
Yeah.
Doctor, from my side, I was trying to use the config files you constructed, but when I run the simulation, it gives me error in the config file.
Yeah, could you please share your screen? Let's see. Yeah. Okay, this config file, yes. Okay.
So just to take you quickly, I copied the files we have. I created a temperature test profile here for test A, and I have the config, control, and field. I run the
oh my. Yeah, as I said, you should copy the config file to we have 3 files for input, right? What's the name?
Yes.
What's the name of the 3 files?
Control, field, and config.
No, it's config. But right now you have what? You have config dot something. That's not config, right?
Yes.
So what do you need to do? You need to rename this file to config file. So if
I use MV and then
you need to rename it. You need to rename it. I don't know how to say this. You need to move or config. Yeah, you need to move or config. Then to config file, CONFIG. Yes, enter. Now you can do it. Yeah, there will be no error message. Yeah, you can do the tail right now. Tail F. That's a trick. All right.
Okay.
You see? Now everything good. Okay. That's why I emphasized again and again. Yeah. Yeah.
Okay.
And it's good for others. Yeah. If you're now you want to change it to another system, then you just need to copy one. You need to copy config.f. For example, 5 by 5
I saw this in the video again. Yeah, I saw it in the video game, but I thought we're just renaming it. We don't have to change the name.
That's why we need such project. If you do not have hands-on experience, you just go through, look at the tutorial, super easy. But if you do it by yourself, you understand what these details. Yeah, what these details. Yes, it's very important. Yeah. All right, thanks for sharing this. So for all the others, if you have the similar arrows, you will see how to do that. All right.
Yeah. Doctor.
Yes, please.
Actually, I have many questions, but the first one is in Python.
Yes, please share your screen. What's the issue for Python?
Let me share. The 2 graphs that does not come separate, always together like this one.
Yeah.
And one above.
Okay, that's good demo. All right. You're right. Your plotting is good. Let's go through it first. Yeah. So you have import pylib as PL, good. And M1. You have 2. Now you have.
Let us start with the 333. They are the same coding, but in 333 I have reached equilibrium.
But
all of two files have the same name.
you
I
have
think
the same name. That's not
yes,
good. You
same
should
name.
change the name. You should remove. You know how to rename a file. It should be the different folder. All right. Each folder you have one energy file. Then you should this file should have different name in one folder, or
Do you mean energy that?
in different name. Yeah. Yeah. Please.
So M1 should be in different file.
Yeah, you should say M1 equals energy dot something, energy dot T1, right? And another energy dot T2. You need to rename the file. Yeah.
For the energy. But Doctor, I have read that in the tutorial, the energy change while I am changing the temperature automatically in the same folder or in the same file, like
No.
this file.
For each temperature, you should use a new folder. All right, you should use a new folder to do the simulation.
Because I only have this folder, and I change in Ubuntu and control the temperature and run everything in Ubuntu and plot it in Python until I reach the equilibrium.
Yeah.
That's it.
So
And it's changing.
when I previous tutorial, I just do that just for what? Just for the convenience, because you will see T1 or T2, that's convenience. But here you will see you have the two together. In general, you do simulation, you have one temperature as one folder. All right, you do the temperature, another temperature, you will make a dir, make another folder, and the and they change the they change the control file, etc., and run the simulation there. So you will be separate folder. Then you can say copy this energy file, rename them to a particular we are renaming them to a different names. Then you can put together to plot. Yeah. And
so
okay,
in this file, in this folder,
plot, sorry.
In this folder, should be containing many temperature, at least two.
Yeah, one folder, one temperature. All right, one configuration. Yeah. If you change to another configuration, please make another folder. Another. Yeah.
Okay. And the second question about the 444. I started the 444, but whenever I changed the temperature, it did not reach the equilibrium. I have tried from 1 to 10. Then I went above until 50.
Wait a second. You already know what means equilibrium, right? So you will
like this one. This is an equilibrium. Then in phase
exactly.
Then,
so you only can take the function phase is 0.6 after 0.6, right? The previous you just take is this preparing phase, called the equilibrium phase. Yeah. So after that, after 0.6, that's function phase. Then you can have the average data from the function phase only, right?
So, sorry, I didn't get you.
So I'd like to say that the data of the first 0.6,
This one.
6, million steps. That's just a trash, right? It's not equilibrate. Right?
Yes, I know.
It's useless. You cannot use that, right? So for your data, for example, here, could you please grant my my control? Right, I use your data as an example. All right.
Okay.
Yeah.
This is Victor. This plot is for the 333, not 444.
Okay, it's fine. I just want the demo. All right. So for example, you have all the data right now is how many? It's about 1 million, all right, 1 million steps. Then you say, what if I want to plot what? I just want to plot 0.6 million. So let's see.
6,000, 600,000.
Yeah, you just do all the data after 600,000. All right. So everything you just change one. Okay, actually, it's better to do this way. So say you have a K. K is the steps needed for the function, right? So that's the easy way to do this. Is this. So you have a K, and this X, this Y. You do this because L2 is useless. You do not need to do anything here. We do not need to plot. So let's say we do this. Suppose everything is correct, right?
You are plotting in 444, Doctor.
Okay, maybe could you please go to 3 by 3? Yeah, do the similar. Okay, you go to do 3 by 3 by 3.
Okay, the same.
Yeah, you just take 1K. This K is the steps for the useness data, right? For the equilibrium. Yeah. Okay. Okay. Good. Say.
Same.
Do you have energy data there?
Here.
What's the error message? Say. Yeah.
There is no error.
Yeah. You have run file. You have tutorials 1 by 3. Could you?
Let me check.
What's the error message? It doesn't in C. Doesn't shows.
Without the K.
Oh, okay. Because just slow. All right. Yeah.
No, this is without the K, Doctor. This is the plotting without the K. I deleted the K.
Oh, without K.
Yeah, no, because I deleted the check.
Oh, I see. What's the reason now? Because this K is the total steps, but you have a print. You have a frequency, right? Wait 1 second. I already have control. Sorry. We have a K0. Let's say we have a K0. You print every 1,000 step only, right? And you have the total. What I said. You have a K. You have say you have these total steps in your system. Then say, let's say KK. Then what you really need is KK divided by K0, because that's the data points, right? KK means this one is MC step. How many steps in your simulation? But you do not plot out. You do not print out every step, right? You just print out every 1,000 in your. Yes. I remember clearly in your control file. You have control this. So how many data points in your data? So that's something. Otherwise, you have the error. Let's see. Okay, this time should be fine. Type error. Slice indicates must be an integer, a long, or have an integer method. So let's see. One, we have this. We have a KK divided by 1,000 should be 600. Doesn't make sense here. If I say, all right, that's something called the debugging. Let's see. Why is this? Oh wait, I don't think this you need. All right. Yeah. M1, let's say print. I'd like to print out the M1 size, right? M1 size, not the size, called shape, all right? Called shape. Okay. So M dot shape. So you will know how many data points there. We need to save it first, then run. Okay. We have 1,000 points. So we have 1,000 points. Yeah, because we have 1 million, right? So this we plot only 500. Then what's the issue now? Slice indicates must be integers or long or have integer method. So let's see, we make it to an integer. It asks us, this slice, this case should be an integer because it's an index. Wait 1 second. Save and run. Now, it okays now. Wait 1 second. Wait 1 second. It should be showed up. Because the total steps is not this now. It should be okay. You start from 0.6 to 1, right? It's already changed, right?
Yes.
Difference. Okay. For this is the one you will see fluctuation. This is the useful data. This function phase. So we have this data plotted. So how we get the average? So I just use you as a demo. Sorry for this. Yeah.
No problem, Dr.
To
Ted.
get the average. So we say we'd like to get the average, for example. So we say, wait 1 second. We are automate. Yeah. Say we have EA average equals what? Equals M. You will see already K, right? Functional ones. Okay. Yeah. So this one you're still divided by n already. Let me see. So M average is this. M average is this. Then I just make it. So EA equals MA dot what? Dot AVG average. Wait 1 second. So more or less we need to, last time I asked you guys import scipy as SP. So maybe I say this time is super easy. SP dot average dot MA. Then we print out it. Let's say print EA equals, right? Let's say EA. Make life easier. Right? I save and write. Save and write. It say scipy has no attributes, just no such function. Right? Let's see. Maybe
Maybe the A is capital, Doctor.
AVERAT. I just forgot that much because at each function they will have different, but in general they will have. Wait 1 second. Why we have SP, AGE, and MA, it print out. Okay, they do have the printout. You will see EA, they give you directly, right? So this is super easy. You just remove, what's that? This wording. Okay, this wording, okay, is deprecated and will be removed. Okay, so you guys can check, can Google what's the new function. But anyway, it may be called mean, sometimes called mean. All right, mean, or you can find more about that, or you can do STD. That's function we always use. So I may still in the old memory. Anyway, so this is the easy way. It will give you average, very just in fast. You just print out, and then you will use this data as 1 point for this. You have the one temperature, right? You have one average energy. It's 1 point. Then you have multiple points to have the plot, the energy, average energy versus temperature. Then you will see the jump of this curve. That jump is a critical temperature. You need that one as a in our report, right? That's the goal you need to do.
So, Doctor, we need to find EA for the 5 configuration that we have.
Yes, you need to find the 5 EA, 5 at least 5. The more the better, of course. The more you find more common straightforward. You know, the curve, you have more points in the curve. The curve should be better, right? You have more data.
Doctor?
Yes, I think, okay, wait 1 second. So far, I think it's okay for everyone, right? For the year, how to the coding like this, you need to have scipy, right? You have scipy here. Then you can take the average.
So cool.
It's super easy. And then you take this data in the Excel file, for example.
So cool. Cool.
Please open this in the Excel file. You'll do what? You will do and then average. You do another simulation. You need to build up another folder. And repeat this process. You have another.
Doctor, how can we download scipy here?
This survey is just the last time.
Yeah, I was with you, Doctor, but here when I put the scipy, it showed me like a warning sign.
Okay. All right. Could you please share your desktop so I can solve the issue? All right. This one, please stop sharing so we can go another. Yeah.
Here. Do you see anything, Doctor?
Yeah, I saw your desktop now. Okay. So what's your issue?
This one, do you see it?
That's the warning. That's because you import it, you do not use it. So the system sync suggests you do not need it. So it will be a warning. It's not an error. All right.
So
this warning is not an error. Once you use it, the warning goes off. You will see. The system sync because he is not smart as a human being, right? He think your using this part. Everything goes fine. Please go ahead and use it. You guys will love this system, these tools.
Sorry, Doctor, what do we have to put here inside the average? Like M1.
You should value. Like M1, like M1. The energy for each energy, you need to rename it as something, right? Say your plot is energy AME. What's that? Anyway, so M1 is the data you have. Could you please show that figure again?
Do you want the figure?
Yeah, show me the figure.
Yeah, of course, of course. This
All
one.
right. I want to know your figure just because the first, for example, the first 0.5 million is noise. It's a trash data. All right, it's trash data. You do not need you need to get rid of it. But it's useful just for your judgment. Is not being equilibrium yet. So what do you do? Yeah, what do you do is
in the case of Sultan Al-Awad, now he is having the temperature 1 equal to 1.7 and temperature 2 is equal to 1.9. It is not correct, right? Because
I think it's correct. It's
now,
fine. It's fine. Yeah, it's
fine.
It's okay. Yeah.
Because I'm having the same problem now. I want to represent it in Kelvin, and these values, I think it is for T star, right?
Yeah.
But we have to plot it in terms of Kelvin, right? So how can we convert it from T star to Kelvin? It is written in the code that T in Kelvin equal to T star over Boltzmann constant. But if we did that,
no, that depends on which units you are using, right? It's a little bit different from the tutorial, right? But even here, your temperature will determine by the parameter you have, right? So here is if it's 1.8, it's still reasonable, right? You will see that at the beginning, at the first 0.4 million step, you will see is trying to approach equilibrium, and after that, the system is totally different. So you will see at the temperature, at a different temperature, you're doing good thing because you can think the temperature different, the energy will be different, right?
Cool.
Yeah,
but the temperature
Please go ahead.
Is not in Kelvin. The temperature is not in Kelvin at this point, right?
The energy is what?
The temperature.
The temperature
is the units, right?
Is the convert. You're in the control file you set, right?
Yeah, I will set it in T star. But how I convert it to T in Kelvin? Can I share my screen, Doctor? Can I share my screen?
Please. Yeah, okay, please.
Hold on, please.
Please share. Yes, Sultan. Yeah, please stop, and yeah, please go ahead.
Can I ask a quick question?
Yeah, Hassan.
Doctor, see here. Here,
should we plot several temperatures?
Okay. Yes. Yeah.
Come on, Hassan.
Cover.
Okay. Doctor, see here the temperature. Okay. I don't know how to write it in T in Kelvin. Here it is written 1.428, and I don't know what's the unit of this. Is it T star? What?
So T star, you know what means T star? T star showed in our lecture. T star is the units of the temperature, right? Units of the temperature. So this tutorial, I forgot what's the unit. Originally they use internal, right? They use internal units, right? If you go to the field, they use internal. Then if they want to convert to the K units, then you need to do that. You need to divide by Boltzmann, etc.
Okay.
But in our case, if you just do directly in K, then you do need to do such convert, right?
Okay.
Yeah, that's the units. That's why we have different sets of units. Yeah.
Okay. Thank you, Doctor. Thank you.
Yeah.
I'll stop sharing.
Yeah.
Okay, Doctor, I just wanted to kind of comment on what Abdul Karim said to understand.
Yes, please.
So when we plot, do we need to plot several temperatures?
Do we need what?
to plot several temperatures like 1.1, 1.2, 1.3, 1.4 until we see the cutoff.
Yes, okay.
Or the
Okay, this is a trick. All right, this is an open question, not for you, for anyone. All right. So this, you do a lower temperature, then you know is crystal. All right. You will judge it by two factors. Right.
Mhm.
One, you will go to the orbital to see it's a crystal, right? Last time I showed you is crystal or liquid or amorphous. You will see the totally different. If the lattice is masked, then you know that it's already melting, right? So you will see that at a very low temperature is a crystal for sure. Then you will go to a higher temperature, right? Go to a higher temperature, then you will make sure it's melted. It's just amorphous. Then you will go both ends, right? From both ends to the center to see what's the critical temperature. So you need to test. No one tell you what's that number, because that number changes by all the conditions. Right? So you need to do exploration about that. So you don't know what's that. For example, if the transition temperature is 2, right? And you need to do something around this, say 1.8, 1.9, then 2, 2.1, 2.2, 2.3. There are a few points around this critical temperature. Then you can identify precisely what this temperature is.
And then this temperature, I could later on just use the equation to transform it to Kelvin if I want to write it in the report. That's it. I mean,
yeah, I think this temperature you don't need to convert anything. If you find this is 2, then it's 2. Right? If you find it's 1.7, then 1.7. Write it in the report, because this one already is the K, is already in the K units.
okay.
Yeah. Someone already typed that. Thank you very much. This is very useful, right? So you guys how to do the average. Yeah, you guys do. Great.
Doctor.
Yeah.
About the transition temperature.
Yeah.
How to estimate it at the first trial? For example, if I got in the first one 2, as you said, the second one, how to in the 444 in the 444 configuration.
Okay, if you get a 3 by 3 by 3, then 4 by 4 will be very similar. It will be around. It will not change by 10%. All right, just keep that in mind. The size effect is a small effect. It will not change 10%. Right? If you get 1, 3 by 3 by 3 somehow, then you'll say, all right, the next one should be around that. For example, previously you find is 1.9. Then you will see, okay, it should be around 1.9, right? It's you need to double check.
Okay, and
that's far. Right?
For the RDF, doctor, I tried to solve the third tutorial, but did not plot in the final step. The plotting step did not plot in Python.
Yeah. So if you go through the tutorial,
I went through the tutorial.
Website, they did not have such plot. You need to do it in the Python or in your Excel. Yeah, you can do at the beginning. You need to plot the temperature versus the energy. You will see there are a sharp change of the average and energy.
How to do it in Python? In the same.
Okay. In the Python, it should be the same. You just save the data into a file. For example, you will say T1.data. Then in the Python, you say load, text node. Then your load that file into a variable called, for example, M9, for example. Then you do the plotting as usual.
As usual.
Yeah.
And for the NBT, the same procedure as the
Same procedure. Yeah.
And where it is written in the project file that the pressure should be 0 and we change in the temperature.
Yeah, the pressure is 0. You change the temperature.
What are we looking?
What's the difference in MPT I ask you to do? You need to plot the density. The density also have the output in the file, right? Find the density because each time the configure file will change a little bit. Okay, the beginning it do not change, but once you do MPT, the size will change. So the density will change. So please also plot the energy, this one figure, then you plot another, that's the density. The density change with the temperature, right? You will find a very sharp change of the density during the phase transition.
Oh, so I change the temperature as the transition temperature and observe the blood.
Yes. So you have the x-axis still is temperature. The y-axis, yeah, first you do energy. The second, you need to do the density, right?
The first energy and the second density. And how to change density?
It automatically changed. It will automatically change because you use MPT, and you set the P is the same. Then when you change the temperature, the volume will change. Once the volume change, the density changes. Right?
Okay.
Yeah.
Excuse me, Dr. Bing.
Yeah.
Yeah, I've sent you a question on Telegram. I'm using the same number of steps for the pre-melting and the melting condition. But I'm not getting the same length of curve. If you can allow me, I can show you.
Yeah, please show me. I saw the previous two students, they already showed us. That curve looks good. Looks good to me. Yeah.
Yes, doctor, if you can see.
Yeah, I saw yours. How many MC steps? Okay, your steps is too low. You need to be millions, right? You need to be millions.
Yeah, this is what I'm doing. I'm using 20 million.
Oh, you use 20 million. Let's see.
20 million for the.
Yeah, but it says your MC steps is only 10,000, right?
No, you can see here.
Okay, that one is how many? That's 12 million. Yeah, it's 1.2 million. It's 1.2. It's good for 3x3 or 4x4x4. Maybe not good for 5x5x5. Yeah, from my experience. Yeah.
Okay, so my question is for the upper curve, this one, the blue one. Why I'm not getting the same?
Yeah, you should use a large number. Yeah, you should use large number. Yeah, you should also use 1.2 million steps. Even looks very large number. Your system, you mean your notebook, your laptop, will finish the calculation in a few seconds. It's still just a piece of cake. Yeah.
Okay.
Yeah, do a little bit larger steps. As we talked in the lecture, say this one step, you move almost just one number, one atom. And you should move many times so the system will get equilibrium. That's why we need larger numbers.
Okay.
Yeah, the number, no one tell you which number is good. You need to make such a test, right? You can first, from your experience, you say, okay, I will get 2 million steps. Then you will see as previously the Abdullah shows, we have the two phase, equilibrium phase and function phase. You will see the jump, right? You will see the difference.
Okay.
Yep.
Thank you.
Thanks for your sharing, Misha. Yeah. Other questions? I may, okay, I already take over by the questions, but okay, before the next question, I will require of you, please go through the VI tutorial. The next time, because I use VI for about 20 years, everything in the memory, in my figures, in my fingers, right? Even I type it, I didn't realize what it is because it do not go to my brain, right? So that's why I go very fast. You guys cannot catch up. So I hope you guys, in your time, please go through this short tutorial in the VI. It's asking you, say, you will get it in a few minutes. You get to understand what's VI. So you just follow it a little bit, get practice. That will give you a lot of convenience later. And also, please have the GUI. GUI also give you convenience. For example, I will demo. I will give a short example. All right. So I will share my screen. If I have everything here. Okay, I will share my screen. You guys may find it. Let me check if I have it. No, let me, all right, I try to demo. I will try to initiate this UI. I think all of you already download and install. Well, then install, you just launch it. You just launch it. Say this, you have 3 steps. You just go legs, and the third one, just tick this, make this ticked, right? Disable or something, all right? Just tick this. That's all you need to do. Then you're finished, right? Once you're finished, it will have an icon here. You will see it has already been there. Then you go to for example, Ubuntu. Do I have anything here? I did not. Okay. The program. Wait 1 second. Oh my. I need to go this. I need to load my external drive. Sorry. So I go to program. Okay, I have this. I have the multi seconds. So it will be the multi tutorial. It will exercise. It will tutorial 1 T. For example, we have this PNG. This file we plotted, right? We renamed it for something. We say data T1 to PNG. Then I want to view it inside Ubuntu. So I just do it. We call it EOG. If you do not have EOG, you just sudo apt install EOG. That's super easy. All right. You can sudo EOG. Eye of Gloom. All right. That one is easy to view your figures. 1 second. Okay, it's asking me to install. Sorry, maybe in this system I have not installed it yet. Just easy, super easy. Yeah, just enter. See, we install in seconds.
Sorry, Doctor, what are you installing?
EOG.
Sorry, can you repeat? Can you repeat?
Let's see. Okay. Eye of Gloom. Hi, afternoon. So let me type it. Anyone, let me type it in the chatting zone. So everyone will do it. Follow me. Where's my chat?
Yeah, this is a good idea to know everything.
Everyone will follow. Yeah.
Okay, nice. Did you install something before EOG, Doctor?
So something before EOG, because yeah, please question this, because otherwise I do not have everything. That's something I mount my drive. That's you don't need it. Yeah, just mount my drive. Yeah. Just a shortcut. There's no such comment. I just have multiple comments in by my own style, right? You can do it by your own. It's tailored, right? That's why people like Ubuntu or etc. You can have a lot of your own comments. Yeah, you're writing your own comments. So it's very convenient. Right. Once you do this, so I say EOG and this file name, you will find this. It will show up EOG print in your node icon. Okay, this warning message, it doesn't matter, all right? So you will see immediately it plot out this one. You will see
Doctor?
Yeah. So this time step will be extended, right? So it's not being equilibrated. So this just tell you once you have this, you don't need a spider. Yeah. For me, I just do the teaching to demo. I need a spider in my research. I never use a spider. I just do my way. I hope you guys, you will see, if you find your way, you will do job very efficient, right? Yeah, that's something I like you to have. So this is just a demo, and sooner or later you will find, once you have GUI, you have very convenient GUI. For example, you can open Firefox, etc. You have a lot of capabilities to do. Yeah.
Doctor.
Yeah.
The file FIG one energy, is it made by the AOG or?
No. AOG is just like a view. It's only shows your plot only. It do not editing. All right. So you just to add EOG of your figure name. Right. You have a figure. You have a plot. You have a name of this, right? So you need to get the name of your figure.
So how did we get this plot?
How do we get the plot? Okay, long story short.
Because we didn't do it like previous tutorials. The BNG extension.
Yes, thanks. Yeah, you should go through the previous tutorial. You will see there's a script. There's a script called a script strip. If I show you,
because it didn't work with us last time, Doctor, and we finished the lecture. Help session.
Okay, for this one. Okay, let me see. Okay, let's see. I think all of you have the let's go a little bit up. 1, 2, 3, 4. You guys have this master, right? You have 2 folders, one called exercise, one called script, right? So hope all of you can do this. You can copy the script to the bin. Copy the script to the bin. So next time you have it in the bin, right? And what you have in the bin, right? For example, you say ls bin script. You find what? You find this file. This file is getting the data from your results, from the yum this results. Actually, it's just have one line. You just do it. You can write such figure comments later, but I will just make you to decoding it. All right. So script yum. Actually, it's just a one comment, one line of comment. You just use it. This is a bash comment. You can do, for example, I come back to my previous working condition. You just type this comment. It will also works, but it already have number one here that will take the input. All right, this will take the input. So you will see, I do this. I use bin scripts, and I use strip yam. Then I type energy. This energy is something. Search the keywords. This keywords. You will search the energy in the output. Right? You will get. Once you type this, you have the energy data. Otherwise, you do not have energy data. These comments only generates one file. Generates one file. This file name is energy.data. Why is energy? Because we typed, right? We typed this one, we typed the word energy. So once you have the energy.data, then you can plot it. You can plot it. How to plot? Last time we do not work because it's the comments. I do that last time in another system. I have not do it, but let's say we can do the plots. We can do a program if I have. Check if the qplot is here. Qplot, yes, qplot.py, then energy.dat, right? I can plot it. Your mileage will be different because this one is a program I already wrote, and you will see it will plot. It will plot. It do the plotting. So it will plot this file again. You will see a new file. You will see the new file because it's just generated. Then you will see what is. You will see immediately. Yeah, you will see immediately what it. So it's very convenient, right? You do back and forth.
So basically AOG is just like showing the picture, not
exactly. EOG just to show you the figure. Otherwise.
Okay, so what's the point? Because I thought it's like will plot or like instead of spider.
All right, if you plot, it will be in a file.
Yeah.
Being cannot read it.
We can't plot because we don't have the program that you have here.
Yes, you can open it in Windows. In Windows, you can also do that, right? I here just for the convenience of my own style, right? I do not go back and forth to the Windows. I can do it right now on the command.
Can you introduce your qplot file in like VI editor so we can see the text?
That one is a very complex one. If I say this file have many lines. All right, this one eventually you have time. I hope you guys to be good at this. You will write a program.
Oh my God!
You will take all that. You will see how many lines is 1,000 lines. All right.
Oh my God! How can we get this one, Doctor?
Yeah, you need to spend the time on this eventually. This is a very complex one. It plots almost every data, right? This is something that's more or less. Eventually, you guys, you can open a company for this. You will develop your own your software. You can sell the software, right? Yeah.
I think we can get it from Python library, right?
Yeah, it's very basic. Each line you know it. Each line you know it. All right. Then you eventually you have a complex program. You will have your own program later, right? Just a little bit time. Then you have your own company to sell these programs. Yeah.
So are you selling this code, Doctor?
Pardon me?
This one, are you selling it?
I might. Yeah, it's take yes, it's take 1,000. It's about 1,000 lines. Yeah, something.
Oh.
Yeah. Yeah, but once you know how to write, the core part is already similar to the spider, right? To the spider. In the spider last time I showed you guys just the 4 lines. You can have a figure. Right? Very similar. That's a simple one. Then once you want it to be a program, you will make it very say you can deal with many situations, like the Windows, right? In the Windows, previously the core part is very small. It's only maybe the core lines is not that much. But right now the Windows become somewhere gigabit. That's large, very large. Because you deal with many complex situations. But in the core part, it's still very simple. Like Bill Gates, when the first time he opened the company, it's still just a few less than 1 megabit, right? The Windows. It's a simple one. So everything have a small start. I hope all of you get familiar with the commands, with the typing, with the keyboards. Then you can eventually build up your own program. You write your own program. Yeah. Questions? Yeah, that's something. Once you go through this semester, next semester, eventually you will be an expert. All right.
So for the time being, we can't do
our program trying to train you to be good at computations. Not only computational materials, you can also learn the programs. That's why I'd like to have this additional programming session. All you guys spend a little bit of time. You will be a programmer. If you later you do not do the material, you can also have other options to be good at. All right. Yeah. Questions so far? Sorry, I chopped you.
Doctor?
Yes, please.
I try to download GUI. But,
GUI, yes, GUI. That's graphic user interface. All right. GUI.
Yeah. I sent to you in the chat, but then I get the permission denied. I don't
Wait
know.
1 second. We have how to install then. Yeah. I'm still sharing, you guys. Okay. Okay. I click. Yeah. You send me the link. All right. Wait 1 second. Yeah. How to install? Yes. Yes. This good one.
Yeah. All of them. It's good.
Yeah.
When I reached to down, please.
You install it.
Yeah.
You must forget. You must ignore my message. I sent you the tutorial in the Blackboard. I write my own tutorial for use.
Yeah, but because your tutorial for Windows, but my laptop it's Linux.
Oh, I see. then you do not need this interface. If you are Ubuntu already, then you already have everything. You have a super. You are super.
So I don't need the GUI.
You do not need a GUI. You have everything. You are native.
Okay.
Yeah. You are the super ones. Yeah.
What about the second one? I forget. It's like a server.
No, what means the second one?
You upload. Wait a second.
Could you please share the screen?
Okay.
Yeah. Yeah. I tell you the truth. I designed this, ask you guys to do Ubuntu inside Windows, just because I'm trying to minimize your learning curve, right? If everyone start from, like this, just black and white, the screens, you guys maybe grab you crazy around this. If you have a native Ubuntu, then it's have a lot of convenience also in the computation. You already have GUI, so you do not need to install GUI. You have a lot of tools already there, so you do not need to install WS2, and your Ubuntu will run much faster than on the Windows, right?
Even this one, FCX Windows X Server, I don't need it, right?
I did not get your question. Could you?
And what about this one, FCX Windows X Server? Do you see my screen now?
No, wait 1 second. Let me stop sharing. Maybe I get. Okay. Yes. Okay. That's one for the Windows. So you do not. No worry. You are fine. Okay. You have a super one. You have a super one. Yes. Since last time, people have a Mac computer. They ask me how to install this. No. You do not need to. You have a super one. So the same thing for you. You have a super one. You do not need to degrade your tools. Yeah, you have everything. Yeah. For example, here no quit out. If you do EOG, I think you also have EOG. You can reach EOG. Yeah, reach EOG.
How can?
Okay. Reach. No, wait a second. Let me do a demo. All right. Please allow me control.
Okay.
All right. So in general, okay, if I do this, okay, you say which EOG. Yeah, you see, you automatically have it. You automatically have everything. That's why I said you are super. So if you have a file called any figure file, you can open it use EOG, right? So you have everything ready. You just go ahead to do the simulations, yeah, and do the data analysis.
Okay, thank you, Doctor.
Yeah, you're welcome. The other questions? Yeah, that's why I told you each of you is unique. You have your own mileage. Although I give you the tutorial, you will see your situation may be different, right?
Okay.
Okay. Yeah, please stop sharing. And
okay, thank you, Doctor.
Yeah, you're welcome.
Doctor.
Yes. Yes,
to plot the RDF one, we have to add a code, I think, in the control. Yes.
Yeah, you should add 1 line in the control file. Yeah.
But there are 3 integers needed. How can I get them? I think as the tutorial stated in one of the websites.
Could you please share your screen to see what's your
question? Of course. Okay. Can you see my screen now?
Yes, yes,
Okay,
yeah.
this
Yeah,
tutorial 3.
Yeah,
Here, sample
Yeah.
RDF. It will plot for me. Yes.
yes,
It will give me like an RDF file, but there are
yes,
3 integers. Here he gave an example. How can I get these values for my test?
yes. You will see first, let's go cut off, right?
Cut off?
Also, I need to, let me get please allow my control. Yeah,
Okay.
please, I already
Okay.
get the request.
Do you want the control? Okay.
Yeah, please allow the control so I can point to you.
Yeah, you are
Right.
controlling now.
Okay, so first you must understand the cutoff, right? So this cutoff, we already have the cell dimension. You know the cell dimension, the box size, right? So 3 by 3 by 3, 4 by 4 by 4, 5 by 5 by 5. If you
Okay.
open the config file, the 9345 contains the size. Could you please open any of your config file?
Yes, of course.
Yeah, please open one. Yeah, open any of you.
Okay. Okay.
Any of the
Del Monte.
exercise, tutorial 1, do whatever you like. Yeah, 3 by 3.
Let's
open.
go after melting. Do you want?
Config. Yeah, config. Yeah, this one. Yeah.
Config?
Yeah. View it.
Okay. I'm using Sublime Text Editor.
Yeah, it's fine. Yeah, it's good.
Okay, this
so
one.
You will see the line 3. Please go to line 3.
Line 3?
Yeah, line 3. Yeah,
this
what's
one.
the number you are reading? The first number.
4.7622.
Yeah, do you know what that means? That's the size of the box. That's your dimension in X, right?
I think it's for
X.
all the same.
Yeah, so X is the same as Y and same as Z. That's cubic, right? The 3 dimensions are equal. Yeah.
Yes.
So let's go back to the tutorial. Keep that in your mind, all right? 4.7 something, right?
Okay.
Okay. Then that's called cell dimension. Right? Sometimes
so this should be 4.7622.
Yeah, it is 4.76. That's cell dimension, right?
Okay.
So you have 3 cell dimensions. Sometimes it's different. So you say it's asked for minimum. So now what's the number in your system? The minimum and the maximum are the same. That's 4.67, right? And what's your cutoff? You need to set it to be half, right? To be half. So your cutoff is divided by 2, right? That's 2.381. You need to set that, right? That's simple one, right?
Because the default cutoff, I think 2.5, so I have to change it to 2.38, something like that.
Exactly. But this is just for 3 by 3 by 3. If you go 4 by 4 by 4, could you please go to 4 by 4 by 4? Yeah.
I didn't do it, but
all right.
Okay. I think I can go.
Yeah, you can do easily. You can go to 4 by 4 by 4. Just give you guys a little bit demo. Wait 1 second. Someone asked for admit.
I will see if I have them or not. Okay, 4 by 4 by 4.
Open it. Yeah.
This one.
Okay. Yeah. Now you know the dimension. What's the dimension now? 4 by 4 by 4.
Yes. 6.3496.
Yeah.
Over 2, it will be 3.1748. The cutoff.
Yeah, it will be 3 point something. Yeah, but you will see the cutoff. The cutoff should be maximum. The maximum number is the half, right? It should be smaller than that, smaller than half, right? So you say, if you say, I want to have a cutoff 2.5, then in this system it's okay. But in the previous one, 3 by 3 by 3, you find the 2.5 is too large because it's larger than half, right? You need to adjust that. Yeah.
Just a misconception, Doctor. Here, he has 5.0, 5.0. So his cubic size is 10, the double.
Yes, that's 10. Yeah, it's okay because you can. Now this number have no meaning. The meaning is the units. What means 5 meter or 5 nanometer, right? That's different. Also, what different size of the box, how many atoms inside? Maybe they have the unit, the box size of 10 nanometer, only have 1 atom inside. So that's the example is may not the same as what you really do. Right? Keep that in mind.
So sorry, Doctor, but to qualify, clarify, here we have 6.3496. The cutoff should be this number divided by 2.
The maximum number.
Yes, this is the maximum.
No. I mean, you have the cutoff, right? You have your freedom to set the cutoff. So you will have a set cutoff range from something to 3.175. Yeah.
Yes.
Yeah. So your cutoff is not good to larger than 3.175, right? It's good to set to be 2.5, to be 3. If you set it to be 4, that's not good. Right? Yeah, you have your freedom to set the cutoff. If it's fixed, then they comment just give you fixed. Right now you have your freedom. Do not make it too large, larger than half, right?
How could it affect how could it affect our system, the value of the cutoff?
You cannot fix your system. You fix this time, next time will be different. The only way is you know how to change your parameter. You understand the parameter. The next time you do other different system, you need to adjust that number, right? So
I got your point.
Yeah, the first int is the number of grid points. So how many bins, right? You can use a multiply of 10. So more or less is set a multiple of 10. So you can set it to be 10, 20, or whatever. All right, to give you an example, so you can set 500, so something. What that means? That means, for example, you already set a cutoff of 3, right? You already set a cutoff of 3, for example. Then you have a number of grid of points, the number of bins. What means the bins? Bins is your binary. Okay, it's a small part. Let's see. I do not have an example. So that means your divide. For example, you have 10. You set 10 here. That means it will divide this 3, the cutoff, into 10 parts. Right? You have 10 parts. I have 10 parts. If you set it to be 100, that means your cutoff. Your cutoff is a length, right? Your cutoff your length into 100 parts in 100 bins. What does all right? If the atoms then someone is talking. Please raise your voice. Okay. So this just let you know how how small or how large of your bin, how dense or you get the data, right? The third number is the integer that describes the number of steps, right? So you take a total number of 1 million. So how many RDF you want to take? Say, I just need two number. The start is 0 and the final one, 1 million. Then you set this number to be a very big one. For example, you set 1 million. Or 5,000, then you have another plot, another data output, right? If you have set to be 100, then it will have many, plot out. You have many curves.
Dr. Ping.
Yeah.
Yeah, I've asked you like before about the graph I got in Python. So you told me to increase the number of steps. I did and I got the same same graph.
Yeah. Could you please share your screen? Let's see. So you finished the one calculation. Let's see. Yeah.
Yeah, sure. Just a second. Yes, doctor. So here, as you can see, I have the number of steps, 20 million.
20 million. All right, that's a lot. Yeah, a large one. So okay.
So sorry, I didn't share the screen. I said only this one.
Yeah. So for 108, for 3 by 3 by 3, you do not need that large number. Yeah.
Yeah, as you can see, I got the same graph I showed you before, even with the 20 million number of steps. So I don't know what's the
Doesn't
issue.
make sense. Doesn't make sense. Let's go to your details. All right. Let's go to your folder. Go to your folder. Go to your simulation. Please.
The Ubuntu?
Yeah, Ubuntu. Yeah, Ubuntu. Yeah, you need to share the desktop so we can have everything.
Yeah, sorry. Where is it? Show all windows.
Yeah.
So.
For 3 by 3 by 3, 1 million should be okay. 20 million is super. Yeah.
Yes, doctor.
Yeah. So you have 3 by 3 by 3. Okay.
This is for the melting. So I got the melting temperature by the
okay,
side.
wait 1 second. Wait 1 second. I know what I mean. Could you please let me control?
Sure.
I will request. Have you received? Yeah. Please increase the size a little bit so everyone can read better. So it's fine.
Yeah, you have the control.
Yeah, so you will go here. The right click doesn't show up. Please change your font. Change your font to be 40. Now how to do that? You right click on the top of this window, and if you give the property, right? Give the property, then change the font size. Can you do that? Because it's not controllable. In node 1, go to the property. Go to the property.
Yes.
Font size. You will go to font. The font.
Okay, so font size.
Yeah, the size. Go to 40. Yeah, go to 40. Go to 40. In general, yes, okay. 36 is okay. 36 is okay. Yeah. Yeah, everyone like it, right? It's much larger. Yeah. So I think you already have my my control. Okay. I know that. Let's see. You said energy data. I think I energy data. So you should have 2 million, but you do not have 2 million here. That means you only have 13. You have only these steps. So your energy should do what? You should redo the energy. I think you forgot these steps. So what do you do? Have the script? No, you forgot to do that. Yeah, can I do it for you? Just right. So in your let's go back about 1, 2, 3, 4 steps, right? 1, 2, 3, 4, 5. You need to do 5. All right. So you will see the scripts, right? We do copy A scripts to what? To bin. So this next time you can easily use the script in the bin, right? And we go back. Please find all the tricks. I have no time to explain to you because all the memory in my fingers, right?
Okay.
You will see, you will notice the trick, how I quickly go back to my previous folder, right? Those are tricks. Please find it later by your own. So now we need to do what? We need to do table, we need to script, need to script, yum. Then we do the energy again, right? Then you will find what? You find the difference. What's the difference? Why?
Yeah, it's the energy
Sorry,
dot
because
data.
I typed the one more. I should use this. I should use energy. So overwrite. Right. So overwrite your old ones. Okay. Let's remove this one. You guys know how to remove files. Sorry. I have this data. And it will, okay. Now let's do the plots. Let's do the plots. No, I don't need to do plot. Let's check. Is this the size you like it or not? Wait a second. Why everything you have this only? It's weird. It's weird. Your system.
You can view the control and you can see the number of steps there. So I've modified.
No. Let's get your control. All right, get your control. You have set these steps. Your print out. You have this. You have the prints. Everything looks good, but why? That's yum. Let's say you have this. You have this. We have 1 second. We can go to this. You have the temperature 1.5. You have the time step. And then have the energy. So you guys know where the energy comes from. That's just because the system that the scripts do something like that. They just, so sometimes we can do easily in another way, right? Let me double check. We do the energy and I will check the previous one. So I will do that. I will remove the VDW. I removed the VDW. So great. Then let's see how many outputs. Yeah, why is only 138? It doesn't make sense. Let me double check. Debug yours. So you have control. You have the control, and you have young data. It doesn't make sense. Let's go to young again. I don't think it goes to 20 million. I don't think it has 20 million. Now your time step is only this. You do not go to 20 million. Something must be wrong. Must be wrong. Yeah, please double check. Let's debug it. All right. So for example, we go outputs to see how many of you. We'll see. Let's go to the. You're something wrong. You have something wrong. You did not complete. Your simulation is not finished yet. Your simulation stopped in the middle, right? For the other, you guys, for the other, let's go back to another one, for example. Let's go to the pre-melting, for example, right? Let's go to pre-melting. If I have it, everything good here. Now we have melting.
It is energy1.data.
Now wait 1 second. I want to check everything's right. So it's different from previous one because you do it in the 2 o'clock. So let's see. We just want to check the output. To check outputs. Now, let's see.
Doctor, I think because the number of steps is too large, Ubuntu took lots of time. So I closed it and I restarted it. That's why
I see.
The simulation.
Yeah, that's give the reason you do not have 20 million. Otherwise, it will be a good number. Then you can plot. That's explained in your strange figure. Yeah, in your strange plot, you have one is very small. You have part of it because you only finish 13%. Maybe you just only finish 13% of calculation. Yeah.
So yeah, I will decrease the number of steps and I'll do.
Yeah, once you finish, you will have the complete figure. Then you will find the equilibrium phase and the function phase. Then you will have the data from the function phase as in our previous demo.
Okay, thank you.
Okay, I highly appreciate you guys trying. Yeah, we learn stuff from our error, from our mistakes. Yeah, so each mistake, once you share with others, the others know, okay, we could not do that. We gained knowledge, right? Oh my, almost 2 hours passed. So I know you guys still have some questions, but let's stop here. You guys can discuss in the group, in the Telegram, and hopefully, if necessary, I will have additional programming sessions. All right, it's fine. If you guys like, okay, we really need another programming session, I will try my best to help you. All right, I will try my best. So let's talk more about that in the group. If I will set up additional programming sessions. So I already extend the deadline, but please try your best to play with it spend the time and have your program, have your report ready. All right, project ready. Yeah.
Doctor, could you make it a quick introduction about the phase change, the graph? Because E versus T, because all of the tutorials, it's not I think mentioned about this graph.
No, the tutorials is just you know to run one job, all right, one job. But in our program, you need to run multiple, so you can plug them together to show the difference, right? So you need to show the curve. There we have a sharp jump in the energy, in the density. You have a sharp jump. Then you know the transition temperature.
Yeah, do you mean I will find the graph by the density point? Or
so you will not just do one calculation. You need to do multiple calculation. Then each calculation just be 1 point of your plot, right? Then you have multiple points. Then you connect them, you have a plot.
How could you make it?
Energy versus the temperature. For one temperature, you have one energy. You have multiple temperature and multiple energy. Plot it.
It's clear, but I mean the data, from the first tutorial or combined files.
All right, the first tutorial just ask you to do one simulation. One simulation, you only get one data, 1 point, right? 1 point. You have one temperature, for example. Then you get one energy, right?
Yes.
You take an Excel file. You take an Excel file, a table, right? So temperature 1, for example, 1.5. Then you have energy, right? Then you do another calculation. You do 1.6, for example. For example only, all right? 1.6. Then you have another
multiple temperature with
you change the temperature each time. Once you change the temperature, you need to have additional folder. All right?
Okay, no problem. I got it. Thank you.
We'll do a serious calculation. Yeah. All right, each calculation only take you a couple of seconds. Right? You can still finish the whole project in hours. Right?
Okay. Thank you.
Doctor?
Yeah.
Can you see my comment? This command. Can we use it?
Comment? Yes.
Yeah.
In the chatting session, you mean?
I mean, I just again. I will send it again. Can you see it?
Oh yes, I saw it. Yes, I saw it.
Yeah, can we use this command to run the experiment?
Yes, you can use that. Yeah, you can use that.
And what's the difference between this command and the command we used it in the lecture? I mean, there was a similar command. It was
similar. It's similar. All right. One, they may have the debug. They have more additional information output, right? But that may not be good for you. You just need it. In general, anyone works, right? Anyone works.
Okay. Yeah. Thank you.
Yeah, you're welcome. Yeah, I think I really appreciate you guys. Have the energy still working with me. Yeah, for myself, I will be happy to see you guys follow me to do this. To these things. I really like to you guys spend the time on that, right? It's a saying. The Rome is not built. It's not built up in one day. It will build up, many days, right? Your city is built up by many days. The same for you. If you want to learn the skills, you do not say All right, please tell me. I want to get it in 1 second. All right, you're in the imaginary, right? You need to practice. You need to spend the time on it, right? Especially this not for the scores, right? It's not for the examinations. This the scale will come with you for your whole life, right? Once you know how to do this typing, this programming, these comments, later you will be an expert. You will be someone professional to do these things. You will be debugging, decoding, you will write your own programs. You will be a leader, you will do many things, right? There are a lot of probabilities, but all, you need to spend the time to learn these skills, right? To learn this knowledge. Hope all of you can follow me to achieve your goal, right? You will be proud of it. You will feel you will learn something at least, right? That's all. I'd like to close today's session, and let's keep discussion in the Telegram. All right. All right. Thank you all very much. If necessary, we will have another programming session soon. All right. Have a good night.
Doctor, just
Yeah.
last question.
Yes, please.
About the next session, when it will be?
I have no idea right now. Please raise up if you guys really need it. For example, say Monday or Tuesday, you guys need additional session. Then I will see how many of you. Then I will go for an additional, right? If it's not, then I think I hope you guys can finish by yourself already. I think you guys already so far. I believe you already have enough knowledge. Hopefully, we'll go over this recorded tutorial. You could finish the program, the project one now. Hopefully, yeah. Let's see if you have other
because
questions. Yeah.
I believe that we will need next news session for the tutorial 3 or 2. Inshallah, we will not need it, but
yeah,
I don't think so. So
yeah.
in a Tuesday or Monday, we will talk about it in
Yeah,
the Telegram.
let's see. Yeah, please let me know if you guys are really far behind. Then I'd like to give you another session. Otherwise, I think you already have enough knowledge to finish the project one. Yeah, so far. Yeah, but routinely every Thursday I will give the regular programming. If you need additional, then let's discuss about that if necessary. All right.
Okay. Thank you. Thank you very much.
Yeah, you're always welcome. I will try to. I know the very beginning you guys need more guidance, so that's why I'd like to help. Yeah. Thank you very much. Thank you very much, all of you. Yeah. Sorry, I think two of other guys being blocked because the full screen. I did not notice your request for join. Yeah, but you almost the end of the session. Yeah, yeah. I will put this video on the YouTube, so all of you can go back and forth because some details I already ignored, but you can stop it and see what I typed. All right, you can go back and forth carefully about what I'm typing. Right? Yeah. Yeah. Thank you all. All right. Have to leave. Really have to leave. Thanks. Yeah. Bye bye. Yeah. Bye bye.